Hello, so today we're going to be introducing probability, and we're going to talk about the first two rules we see here. All right, so let's start with the first one we see. It's called the complement rule. Now, basically, the complement rule just says that the probability of an event occurring plus the probability of an event not occurring is equal to 1 whole. So, for example, let's just say the probability that it was going to rain today is 1/4. Then the probability that it's not going to rain today would be 3/4, because altogether, if you add those up, that would be 4/4, and it would make up 1 whole. Okay, so if you look at the top of the page on your probability packet, you'll see it says right here, the complement rule. Complement, you know what you could put right here? The complement is the probability of something not occurring. Okay. So basically, if you want to find the probability of an event not occurring, that's just going to be equal to 1 minus the probability that the event does occur. So the probability of not A is equal to 1 minus the probability of A. Okay, so let's take a look at the 3 examples on the bottom of this page. Okay, and again, the rule is just stated right here. If you want to find the probability of it not raining, you would do 1 minus the probability that it does rain. Okay, so number 1, it says suppose the probability that a particular flight is on time is 0.78. Okay, so this is written as a decimal. You can write probabilities as decimals, fractions, percents, however you want to write them. We want to know what is the probability that the flight is not on time. All right, so hit pause, use that formula, and see what you come up with. All right, so basically, if we want to find the probability that the flight is not on time, okay, that's just going to be equal to 1 minus the probability that it is on time. So 1 minus, and the probability that it is on time is 0.78. Okay, so that's going to be equal to 0.22. And you can write your answer however you want, unless it specifies. If it said to the nearest percent, that would be 22%. You could write it as a fraction, as 22 over 100, although that simplifies right to 11 over 50. But I'm going to leave my answer as a decimal, just because that's how the numbers were given to us within the problem. All right, so if you can hit pause, try out number 2 and 3, and then we'll go through those. All right, number 2, Kendra makes 4 out of every 5 foul shots. So, I mean, we could make that into a fraction, right? We could write that as 4/5. She makes 4 out of every 5 foul shots. So what is the probability that she misses her next foul shot, so that she does not make the next foul shot? All right, well, if we want to find the probability of not making a foul shot, we just do 1 minus the probability that she does make a foul shot. All right, now let's think about this. This number 1 right here, we can write that. I'm actually going to make it a little smaller because I'm going to make it into a fraction. I'm going to make it 1 over 1. And then when adding or subtracting fractions, you want to find a common denominator. So since this has a denominator of 5, I can multiply this by 5 over 5. Okay, so we have 5 over 5 minus 4 over 5. So that's going to leave us with 1/5, 1 over 5, right? You subtract the numerators and you keep the denominators. Okay, and then finally, number 3. If A and B are complements, then which of the following is true about the probability of B based on the probability of A? Okay, well, if the probability of A and B are complements, that means basically the probability of B is equal to the probability of not A, right? That's what makes something a complement. So basically the probability of B would be equal to 1 minus the probability of A. So I see that in choice number 3. Okay, the probability of B is equal to 1 minus the probability of A. Okay, it's just our rule that's at the top of the page. Okay, now if you turn to the next page, we are going to take a look at our next rule in probability. We're just going to do a couple examples, and then we'll continue on with these in class. All right, so our next rule is, well, it's called conditional probability. You're finding the probability of something occurring given some sort of condition. Okay, so I'm going to read this rule. It says probability of A given B. So if you're given that an event occurs, you want to find the probability of A, the probability of another event occurring. Okay, so that's going to be equal to, you're just going to follow this formula, the probability of A and B, so the probability that both events occur, divided by the probability of B, the probability of the given event. Now, I just want to point out this down here. See this little line going up and down? This symbol means the word given. Okay, so if we could write, we'll just put an arrow there, this little symbol means given. So we would read that as the probability, P stands for probability of A given B. Okay, and it says right here, probability of A given B. Okay, so let's take a look at number 4. Historically, a given day at the beginning of March in upstate New York has an 18% chance of snow. I'm just going to kind of underline some things as we go. So there's an 18% chance of snow and a 12% chance of rain. All right, so then also they tell us that if there is a 4% chance it will rain and snow on a day, then calculate each of the following and explain its meaning in the context of the problem. All right, so we had said that this symbol right here means given. So we can read this as the probability of rain given snow. So this is the given condition. If we're given snow, what we're trying to figure out is basically if it snows, what is the probability that we're also going to have rain? All right, so let's follow the formula at the top of the page here. All right, so it says the probability of A given B is equal to the probability of A and B. So this is going to be equal to the probability of rain and snow. Now, I'm going to teach you a symbol here. This symbol stands for and. Okay, so let me actually put that at the top of our page as well. Okay, see this word and? We can use this symbol, kind of looks like an A that's not crossed, to represent and. All right, so back to this. The probability of rain given snow is equal to the probability of rain and snow divided by the probability of the given event. And remember, the given event is whatever is mentioned second. So divided by the probability of snow. And if you prefer to write the word and rather than use a symbol, you can. A symbol is usually just a shortcut, but if you want to write out the word and, I mean, it's only a 3-letter word, that's up to you. Okay, and same thing here. If you like to write the word given rather than use this line, it means the same thing. But you do have to be able to recognize it if you see it within a problem. All right, so let's go back and read. So in the top of our fraction, the numerator says the probability of rain and snow. Well, right here it says there's a 4% chance it will rain and snow. So 4%, I'm going to write it as a decimal. If you take this and get it at a percent form, you can move the decimal place back twice, and that becomes 0.04. And that's going to be over the probability of snow. So the probability of snow, it says right here, there's an 18% chance of snow. So again, if I take this at a percentage form, I move the decimal place back twice, and it becomes 0.18. Okay, so then you're just going to figure out what that's equal to. I mean, technically, even if you didn't put it in decimal form, you would have had 4 over 18, right? And doesn't 4 over 18 just simplify to 2 over 9? Now, here's the deal. I would leave it as 2 over 9 because if you plugged in your calculator 0.04 divided by 0.18, it would give you 0.22222 repeating. And we don't want to round unless it says to round. So whenever you change it to a fraction, even if you had plugged this in your calculator and hit math, enter, and change it to a fraction, this is an exact answer. Whereas since 0.2 keeps going forever, you'd eventually have to round it on your paper. Okay, and we don't want to use the whole 0.2 bar, right? We don't use a bar anymore because you can't ever substitute a bar back into a problem. All right, now here's the thing. They want us to explain its meaning in the context of the problem. So basically, the probability of rain given snow, it just means this. Given that there's snow, so if it snows on any given day, this is the probability that it will also rain. Okay, so again, given snow. So if it's, usually we don't say given snow, we say if it snows on a given day in March, then this is the probability that it will rain in addition to that, okay? So there's your explanation. All right, now let's look at the part below that. Actually, why don't you hit pause and try that on your own because it's super similar to what we just did. Okay, so for this one, they want the probability of snow given rain. Okay, so that's going to be equal to, if we follow the formula from above, the probability of, and you could write snow and rain, or you can write rain and snow. It doesn't matter. I mean, think about it. It's the same thing. When you say the word and, it doesn't matter what order you put it in, okay? I just kept it in the order it says here, but you could have written rain and snow. It doesn't matter. Okay, and we're going to divide that by the probability of the given event. So the given event this time is rain. It's whatever comes second. So we're going to divide that by the probability of rain. Okay, so if we look up at the top of the page, just from before, the probability of them both occurring, or the probability of snow and rain, is equal to 0.04. You could write 4. As long as you keep them both in terms of percent, that's fine. Okay, I'm writing them as decimals, but you can keep that as a 4 as long as you keep the denominator, as a whole number percent as well. Okay, and then the probability of rain says right here, okay? It says that there's a 12% chance of rain. So divided by 0.12. Okay, so if we had plugged that into our calculator, it goes 0.3 repeating. I don't want to, I don't want to round because it doesn't say to round. But if you think about this, doesn't 4 over 12 simplify to 1/3? Or if you hit math, enter in your calculator, it'll give you 1/3. Okay, and I don't want you to be fooled. I don't want you to think that this means, like when you have to explain its meaning in the context of the problem, I don't want you to think that there is a 1/3 chance that it will, that it's going to snow and rain. This given doesn't mean and. It means if it rains, given that it rains, there is a 1/3 chance that it will also snow. Okay, we're going to skip number 5 for now, and I'm going to have you flip over. I'm going to have you skip to the next page to number 6. That's the next one we're going to take a look at. Okay, I'd like you to try this one on your own. All right, so hit pause, try this on your own, and then I will go over it with you. Okay, so I underlined the key points, and in part A, they want us to find the probability. I'm just going to underline this to the nearest hundredth that a student enrolled in AP Calc. So we're finding the probability that a student is enrolled in AP Calc. So I guess I'll use a C for Calc. Given, I'm going to use the given symbol, that he or she is enrolled in AP Statistics. So I'll use an S for Statistics. Okay, so again, we're finding the probability that a student is enrolled in AP Calc, given that he or she is enrolled in AP Statistics. Okay, so I'm just going to use our formula. So from the previous page, the probability of calculus given statistics is the probability of calculus and statistics, okay, if you want to use the word and instead of that symbol, you can, over the probability of the given event. Remember, whatever's mentioned second is the given event. Okay, so they tell us the probability of the and, right? 3.6% were enrolled in both. So you could just leave that as 3.6. If you want to leave it in terms of percent, you can. If you want to change it from a percent to a decimal and move the decimal place back twice, you can do that as well. I'll do it the other way this time, okay? I'll write it as 3.6. But again, if you wrote it as 0.036, that's okay. I'm leaving it in percent form. Okay, and then the probability that a student is enrolled in statistics, it says right here, 12.4% of the senior class was enrolled in AP Stats. So because I left this in terms of a percent, I'm going to have to leave this in terms of a percent as well. Okay, and then basically you're just going to plug this in your calculator, and when you do, they want you to round to the nearest hundredth. So I wound up getting 0.29. Okay, and you have to leave your answer as 0.29 because they wanted it to the nearest hundredth. If they said to the nearest percent, then you'd write this as 29%. Okay, so part B, explain to a board member that may not understand statistics what this means exactly. All right, so basically we're given statistics, right? So we want to find the probability that if a student is in statistics, they also take AP Calc. So basically we could say 29% of the seniors who are in AP Statistics are also enrolled in AP Calc. Okay, so there we go. 29% of seniors who are enrolled in AP Stats, right, that's the given category, are also enrolled in AP Calculus.